Hey everybody, today I'm gonna explain you guys the underlying concepts about wireless analyzing and packet replay on the 802.11 IEEE networks. So everything about wireless connections that don't have like internet connectivity. So that traffic I'm gonna explain you guys, and also how from the wireless activity you can get inside the Wi-Fi internet connectivity, like in what way. So those are the wireless access point security protocols. One is the open. You can just interact and authenticate openly on the traffic or internet. And the other one is the wide equivalent privacy. It's can be cracked easily. And the other ones are like the VPA2, VPA3, Wi-Fi protected access. So these are the protocols used usually to authenticate, and I will explain you guys about the encryptions and everything about it more specifically. So there are many encryptions that are used for this kind of protocols up there. As you guys can see, there's a lot of protocols. One of them is AES, which is also commonly used in other encryptions, or like, for example, that are not wireless, like data encryption and stuff like that. And then there's a few more encryption and stuff, but those are just the concepts that you can read up on and understand more deeply. And those are the methods of authentication. So are the methods to authenticate to the Wi-Fi network. There's a lot of stuff going on with the cryptographic and authentication stuff, where there are like encryption in the communication layer that are used to authenticate devices and systems to the network by the passwords. So that's how it basically works. And those here are the wireless networking standards, which are commonly used for networking. And the newest one and the most modern one is the 802.11ax. So it uses also a Wi-Fi 6 latest version of protocol, which transmits data and everything much quicker and more efficiently. So those are the standards of it. And there are also other wireless secure connection methods where you can authenticate to the router Wi-Fi, which is called the VPS, Wi-Fi Protected Setup. The methods and modification to establish connection in VPS are as followed: LAB, DISP, PBC, KPAD. So those are the Wi-Fi protected setup configurations. And now to the very interesting part, the wireless communication frames. These are also frames which the layer 2 network has traffic on it. Those are like work for sending and receiving packets in the network, and they all have the underlying stuff to modify the network, how the devices or the router interact together. So it has a deeper understanding that you will all need to understand, and it's very complicated, but I just want to explain you guys. Those are like mostly packets that you can also look in the Wireshark tool, and this is very important to know. And in the next few clips I will show you the pictures and deeper explanation about everything that is mentioned on here. And if you want to read more specifically on the standards of the IEEE networks, you can go to the RFC page here. And as you guys see in this picture, those are the traffic I captured with the tool called airodump-ng. So I put my wireless adapter into monitor mode with airmon-ng, and then I listen to this traffic. And as you guys can see, those are this cryptographic encryption that are used here, the CCMP, and the other encryption which are used for the wireless access point are also the VPA2 and VPA, as you guys can see here. And the BSS ID is the MAC address form name of the name of the routers, which is also ESSI, or also called in Wireshark capture SSID. And also specifically, if you see here, those are the uptime, how long the routers are already online, and also how many days. And VPS are the protection setup protocols, where also you can authenticate in a different way by pin codes. And if you can see here, those are the manufacturer information, where in what company the router got manufactured. And if you look down here, those are the business ID or the MAC address formats of the router names. And the stations are the devices inside that have internet connectivity or like network connectivity. Some devices don't even have internet but are authenticated inside, but some have, and they just have internet, of course. So I did a test, for example, with authenticating myself to the network. I first disconnected and authenticated, and when I listened on it, you guys can see here it shows epool and also the router name. And epool is used to authenticate, and also these are like the authentication protocols which are used for authentication, of course. And if you guys see the PVR are the things used for seeing how strong the signal is. So the less the signal is, the more the, let's say, speed or like connection to the from the wireless adapter to the specific router is. And as you guys can see up here on the router template, or like the segment here, the routers that are most far away, they have more higher PVR, as you guys can see here. And the data are like, for example, the data that are running inside the network. They could be network data or any kind of data that get transmitted around. And the channel are like the channels which are aligned to the wireless network around. And there are more specific informations, as you guys can see here. And also beacon frames that I'm going to explain in the Wireshark capture more specifically. And one thing that you guys also should know, there is the E up here. This means it supports QoS data. Those data are like supported by routers to give more specific support to the specific devices to have better internet connection inside the router itself. So, but anyways, I'm not gonna explain you guys everything too much in detail. But for example, if you guys can see here, the VPA handshake, it's a handshake which I described in the last videos, how to crack Wi-Fi password. Those are done by 4-way handshake in the network working to actually get it. And I got it by getting the ePOL authentication, where I disconnected the phone internet to my router and connected it to it back. So that's how I also got a handshake, basically. So that's how it works. And this is very interesting how everything goes around. In the last video, in the VPA2, VPA1, where I cracked the router, I basically de-authenticated the stations or the clients, so they will authenticate again, and so by that you will get the VPA handshake. Basically, that's how it works. Okay, in the next clip, I will show you guys the analyzing of the Wireshark packets next. Hello everybody, so those are the Wireshark capture traffic. As you guys can see here, there are many kind of traffic going around about routers and MAC addresses. So I'm gonna explain to you guys how it works. So as you guys can see here, this is the source of the MAC addresses or devices or routers which send traffic out, and the destination of them is where the packets land. So this means the devices are broadcasting themselves out. But if you guys look at some of the packets, for example here, you guys can see that this router sends packets to this kind of device or other router, which I don't know exactly because we will need to look at the packets but specifically. And those are MAC addresses that are identified as. And also the NO up here are the like the timing from the minimum to the maximum, how long did it go by. And as you guys can hear, those are the protocols which are used to make the network standards for it. And now here we see also the length. Those are the length of the data that gets transmitted, the size of it, how much data gets transmitted. And those like beacon frame acknowledgement frames or QoS data are used to do specific behavior of packets that gets transmitted. They are called frame packets. And there are also underlying options like request to send and then flags with it and a few other options. For example, one of the options is SSID. Those are the names of the routers that you can see here. And also these are the sequence number and a few other options. So for you to understand it more specifically, and what's more important is to look at the things down here. So if you look at the radio information, we can see its physical type and also the data range which it can send out, and also the channel and also the radio frequency which it operates on. And this is also the decimal signal strength, how strong it is. If you go to the radio tab header, we see some other informations also specifically, like the channel flags, like for example what they have implemented inside, and also the antenna signal, the antenna on the router. It could also be like devices or systems that a wireless adapter that's like, for example, my wireless adapter that I use to capture with airodump-ng this traffic. And the frames are like the also the physical layer are like the devices which you use to capture the traffic, and there are the frame numbers and frame length which you also capture everything. With this you basically capture the whole traffic and see like what traffic numeric values or alphabetic values come out of the whole concept. And as you guys can see here, those are the frames which are specified of what they do. So the frame control field specifies for what they use for, basically. So it's the one type is used for management frame, and the subtype is number 8. I will show in the next clips like what it exactly means or what to understand about it. And I will use a specific packet injection tool that I programmed myself to injection attacks on the network. But anyways, as you guys can see here, this is the receiver address, destination address, and the transmitter address, and the source address, and they are all specified in MAC address formats. That's very important to know. And there are some other underlying information, for example, like frame check sequence what kind of check sequence it sends on. And if you go to wireless management, you can see the manufactured data or capabilities in what it has. For example, it has the capability of VPS, Wi-Fi protected setup configured, and those are the hex format in as what kind of I think flag or something in this way they have. And there are many underlying informations that you can see around here. For example, you can see the capabilities. You can see here the network standard which is used for is 802.11n, and which channel it operates on, and the supported rates which it supports, and also the SSID is the name of the router. And these are like fixed parameters. This is like time zone stamp, like time zone where it really got put on. If you sniff it actively, you can see the information. And this is also our like capabilities information in hex format as what it can really do. So you guys can hear transmitter is an access point. Transmitter belongs to BSSS, and also the key OS, the protocol implementation to speed up the device is not implemented inside or switched on in the router. So you can configure the router to actually have this implemented on, and there are many options that are not implemented, and you can implement it, or maybe by the manufacturer standards it doesn't have it. But anyways, so those are my explanation in Wireshark as how it works basically, and hopefully you understand some concept of it. Hello everybody, now we're on the Linux system. So to connect your wireless adapter, you will need to go remove all the devices and connect your wireless adapter like this. I have already connected, so I say disconnect, but you will need to also plug in into your computers that it will work. So also to see the wireless interfaces, we will open a terminal, log in as root with sudo su, clear it, ifconfig, and then this shows the WLAN wireless adapter, as you guys can see here, and the MAC address. So clear this also, and we're gonna put it into monitor mode and capture wireless traffic, and then we will also do packet injection. And I will show you guys how the packets look like if I do with a tool called aireplay-ng, and then I will show you guys how I will do it with my own programmed wireless traffic injection packet tool that I programmed myself. And then I will also show the underlying packets in the Wireshark traffic, and also on the terminal how it looks like. So first of all, we will do airmon-ng check kill, which is used to kill interferences with the wireless traffic, so no network layer traffic or any traffic can have influence on it. We will only list on the wireless layer 2 traffic. Hit enter. Okay, as you guys can see, we killed the process ID 1438 VPA supplicant, and then we will also do airmon-ng start WLAN 0, the interface that we opened for ifconfig. Okay, then clear this one. Then you will type ifconfig again, and it shows the wireless adapter is in monitor mode. Clear it. We will do airodump-ng WLAN 0 mon. You guys can specify the options to 3 VPS, and also uptime of the routers and the manufacturer. So we will capture with airodump-ng on this WLAN 0 mon wireless adapter, like the wireless adapter that we basically put into monitor mode, which can then capture the wireless frame network. So that's how it basically works. We will then capture now the traffic. And as you guys can see, we have the traffic airodump-ng running and got the routers that are going around. So what I'm gonna do now is cancel this. Write airodump-ng WLAN 0 mon VPS uptime manufacturer, and then the BSS ID is the MAC address format of the router. So we will use my router to do packet injection, and then ES ID is the name of the router. As you guys can see here, we will specify it. And the channel you guys need to specify to list on a specific network, where we will then later inject packets inside. 9. Number 9, as you guys can see here, the channel 9. And as you guys can see here, we are capturing the traffic of my router, and we are seeing the clients inside. As you can see here, the 1, 2, 3. Those are like, this one is the phone which is connected to my router and has internet connectivity. And this is my Windows computer that has internet connection. And this is, I think, another device inside my system. It even has like TOS data support here, as you guys can see here, because it has the E ratio here. And well, anyways, I will show you guys how you can inject packets, for example, with another tool from the aircrack-ng called first login as a root password, and then aireplay-ng help. It's a help manual to see the injection methods. So there are many methods specified here, as you guys can see, under numeric values. So the authentication is to kick a client off the network, and fake authentication is to fake authenticate yourself in the network as a station. And there are also other specific options you can use to do packet injection or replay attacks. We will use fake authentication, to show that I can authenticate fake into the station. So first we clear this. We're gonna write aireplay-ng, and then we are gonna write. Let me first look. I forgot how it works again. So you will need to specify the business ID, the access point, and then you will need to specify also the DMAC set, the destination MAC address, which is the destination MAC address, which is the address where you want to send the packet to. I will specify only to inject myself as a like fake authenticate myself in the business ID network. I won't send packets to any clients here. So what we will do is aireplay-ng, and then we will specify the business ID, which is this one. And then we'll specify the tag. Sorry, we need to specify the tag at the beginning first. So I will specify number 1, fake authentication, and then we'll on 0-1, and we will hit enter. So we need to make the values fake authentication, and then do number 1. Missing value. Oh, sorry, we need to write the business ID as A. If you want to attack only the access point as only this one, then you will need to write A. And as you guys can see, we are setting an authentication attack, and it's successfully. So this sends authentication request to the router that it makes a fake authentication. And as you guys can see here, we see our MAC address. If we do ifree-config, you see our specific MAC address here, which is also specified there in this format. If you guys look, this one, because we didn't spoof our MAC address or like make a fake MAC address which sends data inside, so that's why it doesn't show. But anyways, I will try to do the attack, this specific one, and show you guys the traffic in the Wireshark. Okay, we open Wireshark. The network analyzer. We capture on the 1.0 wireless adapter monitor mode. As you guys see here, the fiber home is the MAC address of my router, and you can see the manufacturer is fiber home, and the MAC address is also aligns the same, as you guys can see here. You guys will need actually to look more specifically into the packets if you want to see the MAC address. Here we see there's a MAC address which is same as the business ID MAC address of my router. So if we are gonna plan to make a tag right now, for example, fake authentication, we will stop this one, make the authentication attack, and then switch up at the time where the attack will happen, so we can see the specific traffic that happens. And as you guys can see here, we did the association request to authenticate into the router. It's called association request, and that's basically how we inject the packet inside the network. And there are many underlying ways you guys can manipulate the network and do many specific stuff. So for that, I will use my tool for doing this specific stuff to craft my packets in a specific way. So anyways, now we will close it. But first of all, you guys can see the Alpha is my wireless adapter manufacturer, and it sends the MAC address source to the destination of the fiber home router of the router which I have access to. Or I think that I bought and have it running, but we are just looking outside from the wireless traffic, so we don't have internet connectivity. But as you guys can see, we have a authentication in the station as if it will be the devices inside, basically. Only that we don't have the internet inside, of course, because it will require password to access it. So anyways, we will close this, and I will show you guys a more specific way with my tool how we can send different packets that will also have the same impact that we have the station inside, and I will show you guys how to spoof the MAC address also. You can also do it with aireplay-ng, but my tool has more specific packet crafting which we can do. So I coded the program. If you look at the packet injection tool, wireless injection.python. Oh, sorry, I make the wrong extension name. It should not be like this. It should be Python like this. So as you guys can see, that's the code I used. I use network manipulation programming association, like a tool which associated with the Python also, but it's specifically only used for manipulating network traffic in all layers, all open system interconnection traffic, or any connection in the OSI models. But I did it for specific wireless models and for the frame. As guys can see here, it will prompt the user for input values, and then also there's a management frame to send frames in this area. And then there are the control frames to send specific other frames, and also the data frames. Data frames usually work in the internet connectivity level, so someone will have to have internet connectivity. That's something like this for specifically work. But if you find a way to exploit vulnerabilities or get a way to get access somehow with frame packet injection manipulation, maybe you guys can also get manipulate the network traffic inside in the internet layer where people have interconnection. But anyways, there are other specifications as I mentioned here. Those are like the modifications in what MAC address, destination, or source, or things I want to send out. And also, as you guys can see, those are the subtypes of the frames. So the subtypes are basically the many protocols inside. But if you guys can see here, we can use the management or the control or the data, and the subtypes are the many words or like specific frames that are inside here. And then I specified some other options here to also send the packet, and I specified the interface and some way how the data or of the packet should also be sent. As you guys can see here, what type of frame type and subtype and destination and everything else. And those are additional options, like flag options, specifically if you compare it to TCP packets, where you can send specific ways. But anyways, I will show you guys how it works now. Python wireless injection.py, and if I hit enter, I will need to specify the management or control data frames type, and I will use the 0 for the management one, and I will use announcement traffic indication map ATIM1 is a subtype of it, and I will do specific packet injection to the destination MAC address of my phone. Sorry, it won't let me select like this easily because it runs actively. So if we copy that, put it inside here, we will also make the source address. I will spoof it with the 00000 1 2 3 4 5 6. You can only make 6 specific MAC address digits. Now if what I'm doing right now is spoof the MAC address, so the MAC address will show us this, and the specific packet won't get sent by my wireless adapter, so it will not specifically get told in the network from who it is sent. And then I will write the router specific MAC address of my router, and then I will send a packet count with how many packets I shall send. I will do about, let's say, 100 packets that I shall send. Actually, let's do 50 packets. And then this is the packet interval, how fast the packets sent over. I will do 0.1, it's very fast. And then I will specify the wireless adapter, which is also in monitor mode, as you guys saw before, we run 0mon. And there are like the frame control, field value, and some other specific informations that you can see in the normal standard of the Wireshark frame packets. I will do none of it because I will do not specific advanced packet crafting, but just show you guys what I can do. I will skip all of this information, I don't need that. And I will also skip the second destination MAC address to send to the specific other one. Skip this one, sequence, and I'm injecting packets. And as you guys can see, as I'm injecting packets, I ejected 5 packets. It says packet injection failed, but actually it was successful because well, I did the wrong syntax there, but I will fix the program because it's to make it more advanced. But actually the packets arrived, as you guys can see here, and the client station is 0000000, as you guys can see here. So we injected actually successfully into the network, and I will show you guys in the Wireshark traffic how it will look like. We run airmon-ng. And now if I specify the same attack, 0, announcement traffic indication map, frame, destination, MAC address, which is the phone which I did before. The router, BSID. Packets count, 50 seconds, packets interval. Skip all of this. Inject packets inside. As you guys can see here, it's full of zeros, zeros as a source address, because I specified here the source MAC address where it should send from, and the destination, which the destination will also be the iPhone specific destination as I have here. And I also specify the router, which has all the devices inside. So it's sent specifically inside this fiber home router, so and to the specific client, as you guys can see here. So it shows that unrecognized reserved frame, because this is not recognized in this kind of router traffic. But as you guys can see, I still did packet injection, and this is how basically it works. And with this tool, what I created, you can do specific advanced packet injection. So I will still program it a lot and do it more advanced, and also have other underlying options to manipulate other network traffic that are on the internet connectivity layer, where the devices have internet, and I will do other specific injection on specific protocols that exist. And yeah, that's my explanation today about all the injection of the packets into a wireless traffic, layer 2 traffic. And that's how I showed you guys how to inject with my tool, and also with aireplay-ng tool specifically into network. And from this, what can actually happen is like someone could exploit a vulnerability in a network and find weaknesses and also get access to it, or like, you know, do crazy specific networking stuff that manipulate the traffic of the clients and lead them to other stuff and many crazy things like putting like a kind of denial of service attack that will put the like a de-authentication attack, which will put the clients offline or the router offline and so on. So it's a very big spectrum how you can customly modify your packets. So my tool is basically for to specifically craft custom packets to send over the wireless traffic.